Okay, good afternoon. This is May 29th, 2025, ELEC 1013, Network Cabling Class, Fanshawe College, London, Ontario. All right. So today we're going to talk about pots and how things were started. And while I explain to you things that I will, it will help you with understanding the whole topic. All right. So you pretty much know what who I'm talking about, but let's just go through this whole thing uh, because that person deserves the recognition. So he invented the telephone when he was 29, and his first words spoken on telephone was, "Watson, come here, I want to see you," and that was on March 10th, 1876. Now here's where things get interesting. He refused to keep a telephone in his office. The person who invented the telephone did not want the telephone in his office. Why? Because in his view, a telephone was a distraction. Well, little did he know what's happening right now with all the cell phones that everybody carries around while crossing the street. All right. So, what is it that inspired him to invent this invention, this contraption, quote unquote? Well, his mother was hard of hearing. Now, he also was someone that had the inventive type of mind. So he did work as a teacher in one of those earlier schools for the deaf. And he did some pretty much groundbreaking things when it comes to this type of education. So he was not. Put two and two together. Then he invented the telephone. Speech pathology was of his interest since the earliest years of his life, because of basically his family. His mother was hard of hearing. Okay. Now, if you want, when you download this presentation, you could click on this little link to find out more about him. And of course, we're talking about Alexander Graham Bell, all right? The inventor of the telephone. Okay. What is it that the telephones look like? Some of the first telephones, it looked like this. So here's the mouthpiece, the microphone. You would speak to that, and you would take this earpiece off the cradle, and you would pretty much put that thing against your ear so you could hear. Now, the bandwidth of the telephone lines was quite narrow. It's the telephones then, and pretty much until late 80s, towards mid 90s, the telephone sounded like this. Okay. And the reason for that was because the bandwidth was quite narrow. You only need so much bandwidth to carry the human voice. So the speech intelligibility is there, which means basically you understand the words, but you couldn't tell who it was talking. Sometimes you couldn't even tell whether it was a man or a woman speaking because of the narrow bandwidth. Now, the telephone lines that are today have extended bandwidth because of the technology got better. That's one thing. And the other thing is that, the early fax machines were not able to carry those tones that the fax machines would communicate with, the different tones. And when the telephone line had a narrow bandwidth, it's sometimes the transmission was not possible. So then there was that incentive to increase the bandwidth for the telephone lines, so some of the frequencies could carry better. All right. Now let's see here. Here's the mouthpiece. Here's the earpiece. All right. Now, this is something that is called the Centennial Receiver. That was one of the, well, first, well, originally it was developed, that type of technology was developed for something that was called telegraph, which was not a voice communication. It was just, well, pretty much on and off, or dots and dash that really required, well, very narrow bandwidth, and that was associated with the Morse code. Okay, now let me fire up my board here. How is it that things worked? What was the idea of this? Pretty much, well, you right now you do study you pretty much have some lessons on the electrical machines. So electromagnetism is getting quite more and more familiar to you as you go along through our program. Here, create. Okay, there we go. Here's my board. All right, so, well, the idea is that if you have a magnetic field, here's the North Pole, here is the South Pole, okay? So there's magnetic field going on here, and between the poles, the magnetic field is stronger, and as you go along, further and further, magnetic field goes weaker. All right, so you know that if you have a metal rod or wire, and if you physically move through that magnetic field, that metal rod is going to be introduced to a changing magnetic field. So the magnetic field is going to be weaker around that. And then if you move it, it's going to be stronger and then weaker again. So that is going to produce, well, electrons flow. It's going to produce electrons movement. So it's going to create electric current. All right. So, we got something that we can use. So if you take that idea, and let's say, if you have a coil of wire, oops, so we better get a pen. So if you have a wire and you have a coil, so you have many, many wounds, then the area of the wire that is affected is increased, so you have more efficiency. Now, when you put a metal rod inside that, so let's say here, inside that, and that can be connected to a, well, another circuitry, resistor or whatnot. Okay. Then if you introduce AC here, that is going to create basically buildups and collapses of magnetic field around that. It's going to produce electric current. Cool, eh? So you can take it both ways here. If you move, let's say this is a magnet. So forget those connections here. Let me just erase that. Right here, okay. Erasing that here. Doesn't exist. Okay, let's say this is a magnet that you put in there. And say this is north and this is south. Okay, whatever. This is a magnetic rod. If you start introducing, if you put electric current here, AC, alternating current, you're going to cause buildups and collapses of the magnetic field, which is going to affect that rod. All right, so what happens if you mount it in some sort of way that, this is a primitive way of doing that, but if this is going to be a membrane, then if you start talking to that membrane is going to vibrate as your voice is going to make those vibrations. Then that's going to cause the movement, and that is going to create electric signal according to the voice. All right. So this is basically a transducer. It converts the type of energy from one to another. So there's mechanical air vibrations into electrical signals. And then you can do something because you can send that over a pair of wires. All right. So that would be a microphone. But you can use the same principle if you do it the other way. If you introduce electric current with a voice, so it's going to have characteristic of a voice, that then this is going to create magnetic field around that, and it's going to make that rod move with the same at the same rate that the electric current. So here is a loudspeaker. All right. So what can we do with this? If you have one system like this, let me see if I can draw this thing. Here is a membrane, all right, shape of a loudspeaker. And here would be a coil attached to that membrane. And inside or around it, you're going to have a magnet, permanent magnet. And you have the same thing on the other side. Here's a coil. All right, here's a magnet. And if you connect those, here's one side of the coil, connects to the other side of the coil, and then this other side of the coil connects to the other side, make a loop. So if you have to speak very loudly to this in order for that to vibrate with the same thing. So you're not going to have, and plus you get a distance, resistance in the wire. So that's technically would work, but it would be microscopic proportions. So they would be very quiet. But if you introduce some sort of helping device, such as, for example, a 9-volt battery, and you connect that like that in series, then you can actually speak to this thing here, and you can to hear that quite comfortably. Very simple thing. Of course, the coil, so add this resistance of that, because in many wounds, it's going to produce some resistance, going to slow down the current. So that's the that's the most basic things, the most basic way you can actually introduce that type of principle. And if you go the other way, speak, then that thing is also going to. Now, this is a very simple way of showing that. Of course, telephone set is has much more complex circuitry, but basically involves around that type of thing. All right. So here is something that's called a centennial transmitter. That was the first device of that sort, and first it was before it was done for the telegraph purposes, and then later on things were improved to make this thing efficient enough so you could transmit the voice. All right. Now, imagine one thing here. Years and years ago, if you wanted to communicate with someone, what would you do? Well, you could send them a homing pigeon, but you can only have so many pigeons. So if somebody would go from home somewhere else, they would take their pigeons, maybe 5 or 6 pigeons with them. And if they wanted to send a message home, they would just fix a piece of paper that they would write the message on to the pigeon's leg, and they will let him go. And the pigeon would find his way home. So that was, that was one way of communicating. The other thing would be later on things evolved. You could send a letter, write a letter, put it in a mailbox, or take it to the post office or some kind of a post depot. and the mail would be delivered. So the communication was not as quick as it is now, because right now you can send an email, you can well dial somebody's number on their on your cell phone, and we take these things for granted. But before that stuff that we take for granted now, it was not that possible. Okay? Um, so it was a huge deal that you could communicate with someone on the other side of the city, or maybe in another city, later on between countries. But let's say communicating over a distance period, maybe in a different town, while using your voice. So it was a huge deal. How huge of a deal was that? Well, a movie was made about using a telephone. Now, if you wanted to make a movie today about using a telephone, it would be a pretty boring movie, right? But at that time, yes. Now, of course, the technology making movies was not as great as it is now. So, just a little thing here. You can see this actor's face is kind of brighter at the front than his back of his neck is not as bright because of the film technology they were using. The movie industry was using film with different type of light sensitive emulsion, and the technology was not as great as it is now. So in order to make things brighter and appear a bit better, they would use lard to smidge on people's faces. So as I keep saying that, that's probably why there was not too many kissing scenes because of all the lard on people's faces. All right. Now, for the life of me, I can't find what the title of the movie was and who this actor was. And this actor was portraying um, um, Alexander Graham Bell inventing the telephone and speaking. So yes, it was a big deal. 1926, and look, ironically, this is about using telephone, and this was a silent film. So, yeah. All right. Um, Now, how big of a deal was that? It was a huge deal to have a telephone on your desk, and that's what a telephone on your desk would look like. Not everybody could have that. Actually, very few people could have the luxury of having a telephone that looked like that on their desk. Of course, there would be public presentations um, on and demonstrations on how to use the phone. And look, people would pose with the photographs. It would be historical pictures, naturally, and they would suit up. They would wear three-piece suits to go somewhere and witness somebody using a telephone. Things have gone a long way. Now, as things developed, and here's your first terminology. Well, first, one of the first terminologies here, CO stands for Central Office. Some sort of organized system would have to be developed if that invention would, you know, it would have the invention would have to make sense, and it had to be usable in order to be implemented on larger scale. So, Central Office was developed in order to direct the telephone traffic. And it would look something like this. There would be a human operator with a switchboard. And when you lift the phone off the cradle, a light would light up. And the person who was sitting there, the operator, would do whatever she would have to do, plug in a cord. And so that person who lifted the phone off the cradle would be connected to her headphones, and this would be a microphone that she would speak to. And when somebody picked up the phone, you would not hear something that's called a dial tone. You would hear that old famous at that time number, please. So you would lift the phone, listen, and you would hear a human being talking to you saying number, please. Now, this would probably be maybe a mid to small size of a town, of a switchboard. And, well, I would imagine that the person would request not a number. Maybe they would request, can you connect me to Mrs. Smith's residence, right? And that operator would know where things are here because the telephone exchange was not that huge at that time. Later on, things have developed to be quite more complex. So this would be, I don't know where this would be here, but I would imagine this would be like in New York or Chicago or something like that. Or maybe London, England. All right. So to the point that there was those telephone exchanges would build up pretty quick. Now, pretty much you can see that this is a post picture, but there was a whole work culture that evolved around that. So there would be a couple of supervisors walking around, and there would be a bunch of operators directing telephone traffic between the connecting parties. And over here, well, you can see, well, this would be an international phone exchange. You see that here? This would be wires that are trunk lines. A trunk line is a cable that contains many cables inside, and it would be directed to a certain area. So there would be a direct that would be trunk to London East, London West, or it would be a trunk that goes to another country, and so on. So you could see that there's some different designated trunk lines. And, well, it was not just connecting couple wires. This was already, the complexity of that was pretty impressive in the early 1900s, I would say. And from all that, as technology developed, it went to this. This is central office today. I exposed those CO because the telephone line, there's a technological jargon and technological terminology. That a telephone line is a CO line, right? So you can see CO line. How many CO lines does your company need? Well, we need 20 CO lines, or so on. Right? CO1, CO da 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 da. But now things are so much automated that you pretty much have a data center, and it would be empty of people. There's no people there. So from here, from this whole thriving work culture to this, just the equipment directing the telephone or communication channels. And this would have more than just the telephone, because it would have internet and some other things. The tech stuff, I already explained that here, but this was the telegraphy patent. So here's the battery. Here will be a coil of wire around the magnet, and you would just turn things on and off. It would give you dots and dashes depending on how long you hold the switch. And of course, later on, things have developed into supporting what things would be advanced enough to support the voice, human voice. It took a while. Notice one thing here. There is a line connecting those two devices. So this would probably be a speaker you would talk to, and this would be you put your ear to hear. But you could reverse that process, the direction of it. Notice that there's one line here, and the other pathway for the electricity, the other reference, was provided by the ground, the earth. That's it. So you would stick a rod into the earth on one side and stick a rod onto the other side on earth. Now, this was not a very efficient way, but it was efficient enough for that time. You would have to scream to the telephone for the other party to hear you properly, or properly enough. I remember still, using phones in 1980s and so on. You would still have to talk relatively loud the handset for people to hear you. So things have gone a long way, even during the last few years. A few years. I mean, 1990, something like that, or 30 some years. Now, this was here, this technique that was used, it was called the ground start. Because in order to start the converse or initiate the connection or start the connection, the reference was the ground. When you program the telephone, when it comes to programming telephone systems, because the telephone system right now is it's a box. It's a device that hangs on the wall. It's mounted on the wall somewhere or sitting on the floor. That has all the electronics and all that stuff to work as something that's called a phone system. And the phone systems are programmable. Now, way more programmable than a few years ago. And there are different sections of programming a telephone system. So some of the sections you enter to program the telephone lines. The other ones would be programming the telephone extensions, the individual telephones. And each of those sections would have different subsections to answer yes or no questions or assign certain features or permissions and restrictions and things like that. Now, when it comes to programming the phone lines, I still don't know why still there's an option for a telephone line programming. Like, for example, you can program the telephone line to be a pulse dial or a tone dial. And in order to pulse dial, the line is interrupted so many times per second, and that would represent a number dialed. And then there was a bit of a break, and then there'll be another bunch of pulses, and there will be the second number registered, and so on until you get the number of numbers that the final connection is going to be made, depending on the size of the telephone switch or the telephone system. The telephone switch would be the big telephone switch, like a city. Usually it would be either train stations or later on post offices. Around post offices, or sometimes they would exist on their own. The other way to program the phone lines is to make them tone dial. So in order to dial a number, you press a button and you get a couple of tones being produced. And another question you have to answer is that, do you want the line to be ground start or a loop start? Nobody, I shouldn't say never, never say never, but I would have a hard time imagining that anywhere in the world these days, this type of a system would be implemented with the reference is provided with the ground. So there is no any ground start lines. So you have to program your phone system, the box that's inside somebody's office, to accommodate the ground start type of connection. It's all something that's called a loop start, because you don't use the ground as a reference. You have another line making direct connection. So each POTS line, POTS stands for plain old telephone service, which is the most basic telephone line you can get. It would be utilizing a pair. So one pair of wires per connection. So it would be no ground reference. There would be one wire, and will be another wire. So there will be a loop. So always we'll have to program the lines to be loop start, and I still don't know why the other option still exists in the line programming. Okay, but in many of those phone systems, still that option exists. This is what the telegraph station would look like. And usually it would be around the post office, or more likely in the early days around train stations, because the telegraph lines would have to be, extended from one town to another. And when the railroad was built, the pathway was already established. All you have to do is just stick a bunch of poles along the railroad track, and you have a pathway from one town to another. So those telegraph lines would be um, mostly in the train stations. If you ever watched that movie, Once Upon a Time in the West, one of the first scenes was that there's some bad people come over riding their horses, and they were up to no good, of course. And in order to break the communication, so people couldn't call for help, they would destroy the telegraph equipment in that train in that train station, right? So here's the operator using what's called the Morse code, and this is how that so that would be using the letters represented by the dots and the dashes. And she would know that by heart, and some of the telegraph operators could be quite efficient with sending the messages and reading the messages that are being sent to them. So basically, she would listen to the dots and dashes, and she would write on a piece of paper, letter by letter, what the message is. They could send a telegraph, of course, for a certain amount of money. And what can I say? This probably looks like a selector switch that you can send different lines, maybe to a different town if you want to make a connection. And over here, here's that Morse code key that she would just press and hold longer for a dash, and maybe just press momentarily or just to accomplish a dot. And there's a certain rhythm to sending that and receiving that. So it's becoming quite a bit of a lost art of doing that. There's still some radio amateurs that communicate that way, but that's mostly as a hobby thing. Morse code was an official way of communication up till actually recently, relatively recently. I forgot to check it before I have this lesson, but I think the last official Morse code message was transmitted sometime around 1991. Right? And then the Morse code stopped being used as official way of communication, not even for the SOS. And SOS stands for Save Our Souls. So if there was a distress call, so it'd be 3 dots and 3 dashes. So see here, 3 dots and 3 dashes for O. Da 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 da. So if that somebody somewhere on the sea, one of the ships would hear that, they would try to respond to that because that was the last resort. Titanic transmitted that when it was sinking. And the telegraph lines. This looks more like power lines, but you get the idea. The telegraph lines would be extended over the roads between towns, and right here, that's definitely telegraph lines or telephone lines. Now, those porcelain or glass or isolators would just carry the lines. Now, I'm going to go back to this picture right here. Notice one thing. Here's a DC battery that powers up that line to give it more energy. Notice one thing. For the DC battery, as a DC battery symbol, and no, this is not a mistake. This is actually correct here. The longer sort of like line or prong or line symbolizing the DC battery, that references to the positive side, and the shorter line here, shorter bar, is a reference to the negative side of the battery. So look, the positive side of the battery is connected to ground. And now we could do that because a battery is a free floating device. We could polarize it, connect it to anything we want. So the positive side is connected to the ground, not the negative side. The negative side is actually used for the wire that carries the intelligence, the signal. That's very interesting, and that's an important piece of information for us to know. Now, was that just because somebody wanted to do that and they just flipped a coin? No. Originally, yes, it was the other way because negative side kind of is closer to us in our human imagination to the ground, and the positive side is above the ground, and so on. Right? So that was like that before, in the earlier years. But the problem was, it was the problem that those lines would corrode. By reversing the polarity, making the ground as a positive reference to the line, it solved the corrosion problem with the lines. There's a copper lines, the copper also corrodes. Doesn't rust like steel, but still corrodes. So that's why we have that polarity. Now, here is the tip and ring idea. Another more terminology here. This was the plug that was used by the switchboard operators. If there are any musicians in class, you will reference to that. It's a typical size of the guitar plug or an audio patch cable. They come in two versions. They come with the stereo, so-called stereo plug, or balanced. We talked about what balanced and unbalanced signal is. If you don't remember, just go back to the lecture notes and to our YouTube videos. So for the balanced, you need 3 connections. For unbalanced, you just need 2. So the guitar plugs that are being used are just to use 2 prongs, tip and ring, and the sleeve is not existing. So that ring is that long here. There's no break here. There's no insulator. There's no isolator here. No dielectric. So you could have tip and ring, or you can have tip, ring, and sleeve. Now, because the telephone line has only 2 conductors, which is a pair, we just use tip and ring. So when it comes to the telephone wiring, the way the telephone is wired in that outlet that's in the wall, we're not talking positive, negative, or anything else. We are talking that terminology state from that thing here. One is connected to tip, the other one is connected to the ring. So we're talking about a tip and ring. Right? It's always the phone that is going to be somebody's going to pick it up. Don't worry. Okay. So notice one thing. One thing. I always keep telling you, notice one thing. Notice one more thing that I'm going to tell you. Okay. Tip is always more positive than the ring. See that? Here's a tip and here's a ring. But because of that corrosion problem, things are being reversed. Like this is true here. Now look at this thing here. Here is the telephone. That box represents telephone. Here's the ring, which is negative. And here's a tip that is positive with reference to the ring, but the tip is neutral, or neutral with a reference to ground. Is the same as the ground. The tip is more positive than the ring, but the tip is connected to the ground. Okay. Now the positive. I'm going to. I also made a short YouTube video on how the how the ringing happen. How the ringing is introduced to the telephone line. The ringing signal, so the telephone actually rings. Right? So at all times at the POTS outlet, you will have tip and ring sitting at negative 48 volts. That's always present, and that's DC. Right? So here's 0 volts at the tip, minus 48. Now, if you want to make the telephone ring, then it would introduce 90 volts peak to peak signal onto the tip here. Okay. Actually, no, to the ring. Yeah, right here. And that makes the phone ring. The earlier telephones, they would have couple of brass or whatever bells, and there would be a hammer going between them, so that polarity changing, it would move the hammer go one way or the other, and with the frequency of 20 hertz, and it would make that distinct old-fashioned telephone ring. So it was actually a hammer hitting two bells. It's important for us to know, right? So again, the telephone line idles at 48 volts DC, and it's negative 48 volts DC. In order for the phone to ring, you need to introduce, again, 90 volts peak to peak. So there is some voltage in the in the telephone outlet there. All right. Now the power capability of that is not enough to, well, hurt us. And actually, here, when you download that, here is the YouTube video that it's going to take you to my YouTube video. I put it on the multi-sim. All right. Now, here is USOC configuration. That has to do with the wire mapping. USOC stands for Universal Service Ordering Code. It's a standard. Okay. Now, here's something that's called the RJ11 jack. It's a phone jack. The shape is very similar to the RJ45 jack that we're playing with those jacks right now during our labs. The Ethernet jack and Ethernet plug, same shape, but sometimes different sizes. That phone, RJ11, and RJ stands for registered jack, and the 11 is just a cataloging number, so treat it as a name, that 11 here. If this were 12, RJ12, then it would have more prongs active. You see here, there's a couple of empty slots. That's what makes it RJ11. Capable of 2 pairs. If this were RJ12, there would be 2 more prongs here, but the whole size and physical gabarites, the physical parameters would be the same. In fact, when you have RJ45, which is the Ethernet, the computer jack type of a jack, you can insert, it will accept the telephone RJ11 or RJ12 plug into it. So you could use those Ethernet type of jacks. If you wire them a certain way, they could be used as telephone outlets as well. Okay. USOC wiring configuration, and this is where we're going to stop on this slide because we're getting to the time. Now here, when it comes to pins, I already showed you that during the labs. This is how you're looking straight into this here. 2 middle prongs is pair 1. Then within the USOC configurations, we just go outwards. Okay? We just go outwards. Here's pair 1, here's pair 2, and here's pair 3. Again, pair 1 here. Pair 2 goes around outwards. Pair 3 goes more outwards. This is how we count the pairs in the USOC configuration, and that's not the T568, which refers to the Ethernet type of configuration or wire mapping. Then we have to do that dance that I showed you, right? Blue, orange, green, white. So here, 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 and then blue, orange, green, and brown. But this here is a USOC configuration that has to do with the telephony. We just keep going outwards with the pairs. How does that refer to the original color code? tip and ring. That's why I made those that picture when I explained to you that the ringing voltage. I painted the tip red, and green would be the okay, ring is red, tip is green, because that is the color code. Oh, I lost it here. That is the color code that was originally used. All right, here's RJ11 wall-mounted jack. The red and green, they go to the two middle prongs, and the black and yellow go outwards. So, uh, yeah. So that's now here is the, well, Cat 5e, Cat 6, or the category cable that you can use to wire up the same. So this is the same jack. If you want to cross-reference the old color code with the new color code, and quite often when you buy those wall-mounted telephone jacks and so on, they will be color-coded like that, and you can connect those wires with that type of reference. And usually, you're just going to connect one pair. Usually, we just use tip and ring. That's it. Now, there's some different configurations with dialers that are incorporated into fire alarms or security alarms and so on. You would get the tip one and ring one, but we'll talk about that later. Notice one thing: the telephone cable is looking for the signal with the pair one, which is at the two middle prongs. So no matter what color you bring the telephone line on, because that Ethernet cable can carry what? Well, it has four pairs, so it can carry four separate telephone lines. But a telephone line doesn't matter to when you wire up a jack for just a single line telephone, no matter what color of the pair the signal is coming through to that particular single jack, you just wire that to be in the middle two prongs. I will explain that thing further to you. And in fact, we're going to have a lab that you're going to physically connect things that way, just so you can understand the concept better. Okay. So this is the first part of the POTS and 25 pair color code. This is the idea of the POTS. And next time we'll see each other, which is going to be, well, tomorrow for the 2025 class, which is going to be Friday. And we will finish that topic. We're going to get the second part of. Okay, that's it for today. Have a wonderful rest of the week. It's a nice Thursday afternoon. I'll see you when I see you. Thank you.